Hey Dave.
No, I can't hear you. Can you hear me?
Yeah, I can hear you. Can you hear me now? I think, okay. So you're not able to hear me, is it?
Can you just wave if you can hear me?
Yeah, I can hear you.
Okay. For whatever reason, I can't hear you. So that's that's fine. As long as you can hear me, it's probably as much as we need.
Okay,
I'm assuming I can start now. Just wave if I can.
sure.
So I can start?
Yeah, you can start.
Okay. So I'll start. Alrighty. Okay. Thanks so much, everyone. Welcome to this session. My name is Dave Glover. I'm a cloud developer advocate at Microsoft, and I'm based in Sydney, Australia. This session, just a bit of a note on that. I'm also have a focus on the Internet of Things. So I'll just make this slide set a bit bigger. So just so I move that around here. So you can follow me on Twitter, and I post a lot of content on GitHub, and my main kind of repo there is glove boxes. Now the notes and instructions for this session are on my GitHub. So if you can head off to aka.ms/air-quality-monitor, and you'll find the complete source code and the kind of walkthrough for the session. So anyway, so this session here is about building a air quality monitor solution with a Raspberry Pi, and I'm going to be using IoT Central. And I'm just going to talk a bit about why I built it and kind of how I built it. So please do ask questions in the Q&A section, and I will answer those questions at the end of this session. So this is a photo I took of off my balcony across Sydney about 2 or 3 weeks ago. Like yourselves, we're on lockdown here, and I think probably like a lot of cities in India, the air quality was a lot better during the lockdown. There's a lot less pollution, obviously a lot less cars and people around, and so that's kind of what Sydney kind of looks like at the moment. But about 6 months ago, at the height of the Australian bushfires, which I'm pretty sure made news all around the world, this was a view of Sydney from our balcony. And as you can see, that Sydney, the whole Sydney basin was really blanketed in smoke. And this was kind of what inspired me to go and build this air quality monitor solution. So you can see, so one thing, you can see the view, but on the right-hand side, you can also see air quality monitor readings that I took. Now, the sensor I used is this thing called a particulate matter sensor. And you can see here there's a particulate or PM 2.5 reading, which is close enough to 1,000. And that number, certainly worldwide for health recommendations, should be between like 0 and 10. Now, most cities aren't at that level, but that kind of gives you some idea of just how much pollution there was in Sydney at the time, or really across the whole of Australia for that matter, across all the major cities and areas where the bushfire was burning. PM 2.5 is level or size of particulate matter, which is really quite concerning because it's the kind of matter that can be absorbed into your bloodstream. So it's one of the ones that people really don't like that number to get too big. So this was the solution here. So as I said, it was built on a Raspberry Pi, and I'm using what's called a PMS 5003 sensor. And it's from a company, there's a hat there called an Enviro Plus hat, and the company is called Pimoroni. And you can get hold of these sensors you can get hold of the Europe Enviro Plus sensor pretty easily. And I picked up the actual particulate matter sensor off eBay. Didn't cost too much. And the idea behind that is what I'm doing is streaming the data from that Raspberry Pi and that sensor over to Azure IoT. And you'll see what I've got over here is basically a representation, a graphical representation of the levels of pollution. Now, I took this screenshot relatively recent, and there is no pollution at the moment. So the data doesn't look that interesting. But hopefully you'll get a bit of an idea how this was built. Now, I've mentioned IoT Central. So IoT Central is a software as a service solution, which is built on a number of building blocks that we supply with Azure. So the first one is that it's built on top of something called Azure IoT Hub. Now, IoT Hub is a service there for internet scale ingestion of data from IoT devices. Now, in this case, it's a Raspberry Pi, but it could be a microcontroller, it could be a mobile phone, it could be a whole range of devices that might be streaming up telemetry up onto into IoT Hub. The other thing about it is IoT Hub is also capable of bidirectional communications. So you can not only can you send information from a device up to IoT Hub, but you can also receive information from Azure down onto the device. And you would use that for going to change the behavior of the device. Maybe you want to change the sample rate that you're collecting data on, or things like that. The other thing that IoT Central uses is this thing called IoT Hub Device Provisioning Service. And the device provisioning service is a helper service, and it just makes it easier to go and connect up a device, particularly when you're doing a large number of devices. It kind of manages all the connections and the connection strings for you. And the other thing that this service uses is this thing called Azure Time Series Insights. And I'll show you a bit of that as we go, but it's basically a way in which you can drill into the data. So that's so Azure IoT Central is an application that we have built that lives on Azure services. So IoT Hub, Device Provisioning Service, and Time Series Insights. Okay, so I just want a bit more information about IoT Central. So the first thing about it, it's fully hosted. You don't need to set nothing up. You basically define or basically configure the system as to how you want it to go and work. So it's no code, though you can extend it with code, but most scenarios you would not have to go and code. So you'd code up the application on the device, but you wouldn't necessarily have to do too much coding or any coding on the server. You can go and set up rules and set up triggers. So, hey, look, the temperature goes above 30 degrees Celsius. Maybe there's a rule that goes and triggers an email to go and say, hey, look, you might want to check that the temperature's got very hot here or something like that. You can also extend it. So you can extend it with Flow, Dynamics, webhooks, a whole range of services. That has an analytics dashboard and stuff like that. Really easy to get up and on board with. You can set up a free 7-day trial just to test it out. And after that, you can actually use 2 devices on IoT Central for free. If you go and use more than 2, there is a nominal charge, but you do need to be aware that there is a charge. But certainly for a couple of devices, it doesn't cost you anything, and it's a really good way of getting up and running and building a solution without having to kind of spend any money or really take too much time. So the thing that I love about it is I can get my ideas together on the devices, and it's a really easy way of being able to present those ideas to somebody else. So if you're working on a project for someone, it kind of brings the data to life with a solution that you're going to build. So as I mentioned, you get a 7-day trial, and you've got 2 devices for free, kind of on an ongoing basis. And you can see here that I've got a couple of charts. So I'm just going to show you how I built those charts, and we'll just go through that process. Okay, so just going to go across into, so the first thing I'm going to go to actually is I'll just start up the browser. And I'm just going to pop across to, I'm just going to search for Azure IoT Central. It's by far the easiest way to start. And I would just click on the first link there. And you got this option here to go and build a solution. And you just go and click on that. And you go and, hey, look, create a new application. And you just go in here and define an application, a custom application, and you go and configure that. Now, I've already done that. So, I've already done this already because it takes about 30 seconds to go and do. So rather than us watching the system go off and create a solution, I'm just going to take one that I've already created. So what I'm going to do here, in fact, I'm just going to delete out the existing template that I've got loaded. So this is an IoT Central application that I've basically created just half an hour ago. And you get a dashboard here, which you can go and customize, and the whole dashboard. So the idea behind the dashboard is you go and put the information on that you care about most on that dashboard. And then the first thing I'm going to do is define what's called a template. And a template basically maps the data that's coming from a device into IoT Central. And then when you're mapping that data, you can then go and use that data for going building charts or setting up triggers or doing data analysis or stuff like that. So what I'm going to do here is I'm going to create a new IoT device, and I'm just going to call this one Air Quality Monitor. And we'll click on Create. Now, what I'm going to do is I'm going to import a capability model. Now, I've actually got the capability model loaded up here in Visual Studio Code, just so you get a bit of a sense of what it is. So you can see it's just a JSON document, and it describes the telemetry or describes the shape of the data that's being sent up from the device. So you can see here that I've got particulate matter 1.0. If I scroll down a bit further down here, you'll see I've got temperature. And temperature is a double and things like that. So it's just basically describing what we call an interface. So I'm going to import that capability model. And you can see it's pulled that JSON document in, and it's got all the elements in. So it's as I said, it's mapping the JSON string that is coming, that's sent from the Raspberry Pi up into IoT Central, and is basically mapping that data. And you can go and look at the interface and things like that. You can get more data about the schema and things like that. So the next thing we're going to do is going to create what's called a view. And I'm going to scroll down here and I'm going to select humidity, pressure, and temperature. And click on that. And then the other thing I'm going to select is the particulate matter, those values there. So there's particulate matter 1.0, 10, and 2.5. And we'll add that up. And then I'm just going to save that away. And then I'm going to publish this. I just need to confirm that that this is really what I want to publish. Then I go across to devices. And what I'm going to do now is going to add in a new device. And I'm going to select that template that I just created. And I'm just going to call the device called Raspberry Pi 4B. And then we'll go and create the device. And so that's pretty much all you have to go and do to go and define, imported a template, defined a view, and then I've gone and created a device. And in a moment, I'm going to come back here and get the connection information for that device. And I'll talk about that in a bit more detail shortly. Right, so the next thing I want to do is just talk about how I'm actually building this. So I'm going to use Visual Studio Code, and I'm going to be using something called Remote SSH Development. And I'll show you how that is set up. So as I mentioned already, so I've got the Raspberry Pi, I've got the device connected up to it. I'm using a Raspberry Pi 4, but this will work just as well on pretty much any Raspberry Pi except for the Raspberry Pi Zero, which does not support Visual Studio Code Remote SSH Development for Python. What I actually do is I build the application on the Raspberry Pi 4, and then what I do is I Dockerize it. and then I actually deploy that Docker image onto the Raspberry Pi Zero. So that's kind of how I deploy it. And then I literally just have this Raspberry Pi Zero sitting on my balcony with a sensor attached to it, and it just sits there and just streams out the data up to IoT Central. Now, if you're not familiar with how Visual Studio Code remote development works, it's pretty neat, and it's definitely useful for things like, in this case here, I'm going to be using remote development SSH. So I'm going to be SSHing into the Raspberry Pi, but you can also use it for things like Windows Subsystem for Linux, so WSL on Windows, and you can also use it into Docker images and stuff like that. The basic way it works is Visual Studio is kind of split into two chunks. So there's Visual Studio on the desktop, and that's managing all the UI and the extensions. And then on the device, there's a remote part of Visual Studio Code. And it's responsible for starting up the application and setting up the debugging and all that kind of thing. So I pretty much explained that. So what I'm going to do is show this. So we'll jump across into, so the first thing what I'm going to do is I'm just going to SSH into the Raspberry Pi. So the device is called PiLab. And in a moment, whoops. It would help if I, in the right user. Okay, so what I've just here, I've just to clear. So if I just go and list out the directory, you'll see that these are the directories I've got on the Raspberry Pi. And I'm going to change across into the GitHub directory. And again, you're going to see a whole lot more directories in there. Now, the way that I've got, and I'm going to go into, into the environment. And this is the solution that I'm going to show you. Now, the way that I got the solution onto the Raspberry Pi is I cloned it off my repo. So I did a git clone of that repo link that I showed you before. So that's how the projects got onto the Raspberry Pi. So what I'm going to do now is I'm going to start up Visual Studio Code remote SSH development. And before I do that, I'm just going to show you the bit about the configuration. So in here, there's a configuration file. You can see the host name is PiLab, and this is a key that I'm going to be using to connect to the Raspberry Pi. I've pre-set up the key rather than you watching me kind of go through the pain of setting up the key. There are scripts, by the way, that I've done to make that really easy. So I'm going to connect up to the Raspberry Pi, and that'll make the connection. So that's great. Now, what I'm going to do is I'm going to open a folder. So the important thing about when I'm doing this is I'm opening up the folder on the Raspberry Pi, not on my local desktop. So I'm going to go across to environment. So go across to GitHub, and then I'll go across to environment. So that was a project that I cloned down off my GitHub. And in a moment, this will open up main.py. And you can see there goes the code in here. So the first thing I need to do, besides having a drink of water, is I need to configure up this device to attach it to IoT Central. So what I'm going to do here is I'll just jump back to IoT Central. And these are the credentials that I need. So there goes the what's called a scope ID. And we'll just jump across to Visual Studio Code, post that in, go back over here. I've got, that should be the same, but just in case it's not, paste that in, and the same deal for the key that I need. And we'll just replace that key. Okay. So that's the configuration information that's required to hook up to IoT Central. So what I'm going to do now is I'm going to start this application. So I'm going to go across to debug, and I'm going to click on the option which is to start the current file. And I'll press F5. Now what this will do is that this is starting up the Python application on the Raspberry Pi. And I can step through the code here. And if I hover over those variables, you'll see that there goes a scope ID, the device ID, and the key. And I'll just go and put a breakpoint a little bit further down here so we can see that it comes in. I'm going to run this now. And what this will do is that this will go off to IoT Central, and it will get a connection string. So if I hover over connection string there, you'll see that there goes the host name and the URI to the host. You'll see there goes a device, and there goes this shared access key that this device requires to connect up to IoT Central. And we'll take the breakpoint out of that. And what we're going to do is we're just going to step through this code. So I'm going to step into this, and this is going to step into another class that I've got. So I've got a class called sensor, just a Python class, and it has already set up all the requirements, all the libraries to access the sensor. And we just step through this code here. And what I'm going to do now, because what I do is I do around about 15 samples of the particulate matter sensor, just to kind of get a reasonable take. I found it was better if you're doing this, it's better to kind of get an average over, in this case, around about 15 seconds, given that it pauses for each iteration. So that has been through that. And you'll now see down in the terminal window, you can see there goes the JSON string that I'm actually sending up to IoT Central. Now, if I go across to IoT Central, we'll just close that, you'll see that it's still waiting for data. Now, the data's made it up there, but IoT Central doesn't refresh straight away. Sometimes you can help it by just navigating away from the device, and sometimes you can't. But in a moment, that data will show up inside IoT Central. We'll just give it a bit of a moment. Typically takes around about a minute for the first data to start showing through. So the data is definitely going up there. Give it a bit more of a nudge. So the data is definitely being sent up. Okay, so while it's hopefully going up there, I'm going to keep moving. Okay, I'm not sure why that hasn't shown up. Right, okay, anyway, it will show up, he says, confidently. So I'm going to jump back to the slides. So that's how the data gets up onto IoT Central. He says, hopefully. We'll go back and have a look at there. I'm not sure why it's not getting up there. I will just double check my connection strings. Let me just go back over here. Yep, that all looks about right. Okay. I have no idea why it's not going up there, and it's sod's law for doing a demonstration. Okay, so the next thing I want to talk about and show is some more things you can do on the Raspberry Pi with Docker. So the extensions, so Visual Studio Code has the ability to add in multiple extensions. There's an extension manager over here, and you can see that on the Raspberry Pi, I've got a whole lot of extensions installed. So I've got IoT Edge, I've got some C++ stuff, I've got CMake, but I've also got Docker installed. And you can see that I've got Docker sitting over here in the menu bar, and this will show me what containers are running on the Raspberry Pi. So what I'm going to do now is I'm going to go back to main.py, and I'm going to uncomment a couple of lines. So what this is doing is that this is the Python tools for Visual Studio development. And these tools are needed for remote development of a Python application into a Docker container in this case. I've got my Docker file. So just jump across to my Docker file. And you'll see up here that I'm building a Docker file based on Alpine. And in that Alpine image, I've got Python 3.7, and it's for ARM32, which is it's actually the ARM architecture of the Raspberry Pi Zero. That architecture ran just fine on the Raspberry Pi 4, but because I ultimately want to put this project onto a Raspberry Pi Zero, I are using that architecture. I've got requirements. So if I go down to requirements down here, these are the Python requirements that I need inside my Docker image. You can see I'm also putting in some required SDK, Alpine SDK, to be able to go and build the solution. And then I'm opening up port 5678, and I'll explain that in a moment. And the command that I'm going to be running is main.py. And if I go across to the solution, that's main.py. And you remember I mentioned exposing port 5678. So that is a port that is used for Python debugging. Okay, so the next thing I'm going to do is actually going to build this image. So you look up at the top there, you'll see that the name of this image is going to be environment latest. So that goes off and builds that Docker image. Now that built really quickly because I basically built it before, so it was cached. So the next thing I'm going to do is I'm actually going to start up that Docker image. So I'll go across here. So in the solution file from my GitHub, you'll see that there's a Docker run command for this. And I'm just going to run that command, and that will start up this Docker image and basically starts up the container. Just move that out of the way. And in a moment, you'll see that the application will start up, and it will start streaming data up onto IoT Central. Okay, so there goes the first one. We'll have a quick look at IoT Central, see if it's come to life. And it hasn't, so I really don't know why the data is not showing up. Okay, so now that the application is running inside of the Docker container, what I'm going to do now is attach the Python debugger to the Docker container. So I'm going to come over here, and I'm going to put a breakpoint. Here is probably as good a point as any. And I'm going to attach the debugger, the Python debugger, to the Python application that's running inside the Docker container that's running on the Raspberry Pi. So I'll click on Connect. And you can now see that I can step through this application, this Python application that is running inside this Docker container. So that command there is sending the information up to Azure Central, so up to IoT Central, sleeps, and as I said, as I showed you before, you can basically step through this code. We'll step through there. We'll step into the sensor, and again, we can just pick up the telemetry off the device and send that up. So the tools are really powerful in terms of what you can do to go and build out these solutions. So I love Visual Studio Code, using the SSH development, developing onto the Raspberry Pi. You can do some really neat things with Docker. If you're not playing around with Docker, check out the sample. If we go and click on the Docker tab, you'll see if I go and do a refresh, you can see that there goes the Docker container. I can view the logs. So this is the log of the output from the Docker container. From here, it makes it super easy to attach a shell. So now I'm into the Docker container. So if I go and do uname-a, you'll see that it's Linux, and you'll see the kernel version and things like that. So you can kind of do some stuff. You might want to go and add in additional libraries or stuff like that into the container if you're trying to debug the solution. But yeah, so that's kind of, you can see that those are the files inside the container. So you get quite a lot of power just being able to do using the Docker tools inside Visual Studio. We'll have one last look back up on IoT Central, and for, okay, I have no idea why the data took so long to get up there. But you can now see the data going up into IoT Central. And you can hover over these. So if I go hover over, if I go what's called setting a drop marker, you can set drop markers there just to make it easy to figure out what's going on with the data. You remember before I said there was some analytics. If we go and select the air quality, I'll go and look at the telemetry. I would look at temperature, and I can analyze that data. And the reality is that this solution hasn't been really running long enough. But what I can do is I can go and set an area that I want to go and zoom into, and then I can drill into that data. Now, the reality is there is just not enough data in the system. See if we can find a window to zoom into. Yeah, okay, so there we go. So now this obviously makes much more sense if you had lots of data in there and you want to be able to drill into a particular set of data points to find out what was going on in that solution. I mentioned before rules, so you can go and add rules. So let's just call this rule test. I can go and select the template, and I can go and select the telemetry. So in this case, the temperature, and the condition in this case here. And I just want to say, hey, look, is the temperature greater than 30 degrees? And in which case I want to go and send an email, and you can go and set up a rule and we'll go and do that. Or you can go and kick off a call off to a webhook or something like that. So it could be an Azure function, could be logic apps, it could be your own application using Flow, etc. So hopefully you get a bit of an idea of the things you can kind of do in there. And we jump back in here, we'll see that there's more data in the system now. So I have no idea why it took so long, but the joys of doing a demo. Okay, so that's pretty much the session. So hopefully it gave you a sense of what you can do. I just want to jump back into the slides. Okay, so that was remote SSH development. We Dockerized the solution. I was just going to mention a couple of other projects. So if you head up onto my GitHub, this is one of my favorite ones. It runs on a Raspberry Pi as well. It has a camera on it. And what I'm doing is basically doing image classification. And I've trained up a machine learning model using custom vision. And basically, I just found a whole lot of photos of different types of fruit, labeled those, put them up into custom vision, trained the model, and then deployed that model onto the Raspberry Pi. And also used Azure speech services to say, hey, look, you've scanned an orange, you've scanned an apple, etc. Another project that I would recommend checking out is this Kubernetes cluster. So if you've not played around with too much with Kubernetes, it's building up your own Raspberry Pi cluster is a really awesome way of learning about Kubernetes. What you learn on Kubernetes on Raspberry Pi translates really well to using Kubernetes in Azure. So it can be quite a fun way of kind of learning Kubernetes. I also publish projects on hackster.io/glovebox. People often ask me, what's a good place to go to for ideas or learning about a bit more about IoT? I really love hackster.io because there's a whole range of projects on there using different types of technology. So it can be a really great way of learning about the technology. And if you've done any .NET development, there's also another project up there, which is about how to go and build C#.NET applications on Raspberry Pi as well. We released about 6 months ago a whole lot of open source sensors for various types of sensors that you might want to plug into Raspberry Pi that work with .NET Core. So again, if you're a C# developer and you want to have a bit of fun with IoT, do check out this project. It's an awesome way of building .NET applications, IoT applications with .NET Core. Now, as I mentioned before, so you can find the resources to this talk up at aka.ms/air-quality-monitor. Do check out dev.to/gloveboxes. I have projects sitting up there. My GitHub on /gloveboxes and Hackster.io at Glovebox. You see there's a bit of a naming convention going on there. Okay, so that is the talk. So hopefully it kind of gave you an idea of what you can do with IoT Central. So super easy to go and set up and go and configure. And using Raspberry Pi, I use Visual Studio Code. I use remote SSH development and debugging. And I also built a Docker solution. And then ultimately, as I said before, I actually deployed that solution inside a Docker container onto a Raspberry Pi Zero. And it just sits there. And it's a cheap way of running that solution and having the sensor connected up to it. So hopefully that gave you a bit of an idea of what you can do. Please feel free to ask any questions, and I will hang out here for a little bit for questions. But thank you very much and enjoy the rest of the event. Thank you.
Awesome, Dave. First of all, can you hear me now?
Unfortunately, I cannot hear you.
Oh, okay. So, I'll just it was a really great session, and I'll just